Today we're going to be talking about the law of sines. The law of sines allows us to use trig for situations using non-right triangles. For the most part, before the law of sines, everything we did using triangles, they had to be right triangles, so we could use those SOHCAHTOA type definitions. The law of sines will allow us to work with them using other and all types of triangles. Now, before we go on, we should make mention that we are going to use the standard labeling of a triangle and its parts, that the side lengths will be labeled with lowercase letters, that the vertices will be marked with uppercase letters that are across from those side lengths. So vertex B is across from side B. And lastly, the angle measurements, not the vertex, but the size of each individual angle will be measured and labeled with Greek letters that match the vertex and, once again, are opposite the side. So the measurement of angle A is alpha across from side A. The measurement at vertex B is beta across from side B. And the measurement of vertex C is gamma. That's the letter gamma right there. It's a lowercase gamma. And that is across from side C. So that's the standard labeling that we use when we use the law of sines. So the law of sines is going to say that sine of alpha over side A is equal to sine of beta over side B is equal to sine of gamma over side C. Now, typically, when we use the law of sines, we will not be using all three parts, but we would choose 2 out of the 3 ratios to create a proportion. Remembering a proportion is 2 equal ratios or 2 equal fractions. And then we use our algebra skills and the information given in the problem to solve the proportion and therefore solve the triangle completely, meaning that we want to know all of the side lengths and all of the angle measures. Now, there are a couple of different cases that you can encounter when working with the law of sines. So we're going to work through a few of them. So case 1 here is the law, using the law of sines to solve for, I have side angle side written up there, but that is incorrect. Since if I look at the information, I'm given an alpha and a gamma. This is an angle side angle situation. And we have side length beta. So if I take and draw some random triangle and I label it appropriately, and maybe I call that A, I put a B over here and a C here, and then I can start labeling. So I know angle alpha is 48 degrees. So I have that right there. Angle gamma is 57 degrees. That will be right there. And side length B is 47. And my task is to go ahead and find the remaining sides and angle. I would probably start by finding the remaining angle, angle B, so that's going to be beta. I know that the measure of angle beta will be 180 degrees minus 48 degrees minus 57 degrees because of the angle sum. So it's really going to be 180 minus 40 plus 50 is 90, and 15 minus 105, leaving us with an angle measure of 75 degrees for angle beta. What is left is to find the measurement of side A and side C. And I am going to start by using one of my completely known ratios. Using the law of sines, since I know if I look at this law of sines, what I need to complete any single ratio is knowing the angle measure and the opposite side length to have one complete ratio. If I look at what I have in this particular problem, I have side length B and angle B. So I can start by saying sine of 75 degrees over 47 equals. And then I choose some incomplete ratio from what is left and I will then use what I know for solving proportions to fill in what is missing. It doesn't really matter whether I find side A or side C first. I'm just going to find side A for no particular reason. So I can say sine of 48 degrees, that's sine of alpha, over side length A. If I do just a little bit of algebra on here, I'm going to get, if I start with something like cross products, I'll have 47 sine of 48 degrees equals A sine of 75 degrees, so that A equals 47 sine 48 degrees over sine of 75 degrees. And that's just a matter of plopping that into the calculator to go ahead and figure out what that value is. And when you do that, you get a value that is approximately 36. We don't have any units on it, so we're just going to leave it like that. And then we would do the same thing again to find the measurement of side length C. But now, since I know alpha and A, beta and B, I could use either one of them as my complete ratio. Doesn't really matter. I'm just going to go with the B stuff. And actually, I'm going to use this because I know using beta and B are exact values. If I tried to use sine alpha over A, this measurement for 36 was approximated. I'd rather use exact values in my calculations than approximate values. We knew that gamma is 57 degrees over side C. And if I perform the same operations, I'm going to end up with C equals 47 sine of 57 degrees over sine of 75 degrees. And I just put that into the calculator as well. I approximate it, and I get 41. And so now here, I've solved my triangle completely. I know all three side lengths, and I know all three angle measurements. So I could, if I put those on there, I put the 75 degrees, I get that A was 36, and that C is 41. And I can look at my diagram and see that all three sides and all three angles are measured out there. So that's your first case, angle, side angle. I think I'm going to end the video here, upload it, and do a second video for a couple of the other cases.